In this lecture, we are going to discuss the classification of polymer on the basis of tacticity, tacticity or configuration or stereochemistry. So in this lecture we are going to discuss the classification of polymer on the basis of tacticity, on the basis of geometry, on the basis of stereochemistry or on the basis of configuration. So on the basis of tacticity we can classify polymer into three classes. Number one are isotactic isotactic polymers. Isotactic polymer. So what are isotactic polymer? As the name indicate, iso means same and tacticity. So such polymer have same tacticity, such polymer have same configuration, such polymer have same geometry. So it means, in short, the polymer where monomer are arranged with same configuration, with same stereochemistry. So for example, this is a polymer. Clear? For example, this is a polymer made up of monomer. Clear? And if the substituents, if the substituents are arranged as, for example, or, clear, it is or clear, and below, for example, y, or we can write here h. For example, here we can write h. Clear? So for example, if this is a polymer, it is a long chain of monomer have combined here and have formed a long chain, and if the monomer are arranged in such a way, then such type of polymer is known as isotactic polymer. It can be represented as, for example, carbon, long chain of carbon can be represented as, so for example, this is hydrogen and this is alkyl group, this is alkyl group and this is hydrogen, this is alkyl group and this is hydrogen, this is alkyl group and this is hydrogen. Clear? So by in any way you can represent it, but this will be most accurate representation of what, of isotactic polymer, because such type of method can represent what, three-dimensional structure. This is just like a planar structure, and this is actually shows three-dimensional structure. Okay, so wedge and dash, clear, wedges and dashes show that the some bond is to us. Clear? For example, this is a central carbon, the wedge show, this wedge show the bond is toward me, and the dash show the bond is away from the center. Clear? It means this is the basic of the configuration. Inshallah we will discuss in any lecture in organic chemistry. So this is the representation of what? This is the actually the representation of what? Representation of isotactic polymer. What? Isotactic polymer, and so on. Clear? Here the isomers are arranged in such geometry, in such a manner that every step have same stereochemistry, geometry, configuration. Clear? Okay. So the next is this is isotactic. So the next is what? The next is syndiotactic. What? Syndiotactic. The second one is syndiotactic polymer. syndiotactic polymer. So what are syndiotactic polymer? Syndio means alternate. Syndio means sorry. Syndio means alternate. Alternate. Clear? So syndiotactic isomers are those, sorry, syndiotactic polymers are those polymer in which the monomers are arranged with alternate way. With the alternate way, or the isomers are arranged alternatively. For example, this is a long chain of what? Of polymer. Clear? And if this is a substituent, for example, this is R and this is H. Clear? This is H and sorry, alternate way, it is alternate way, this is H, this is sorry, this is so empty, and for example, this is R and this is H, again this is R and this is H, and so on. Clear? This manner is known as syndiotactic. What? Syndiotactic. Again we can write it as by three-dimensional structure. This, for example, if this is R and this is H, then here this is R, we can write it as, then this is R and this is H. Clear? This is R and this is H. Again if I write it so it will be better. Again here this wedge at wedge it is hydrogen, at wedge here will be R again and H, at wedge it is R, here will be hydrogen, and here will be, sorry, it is, here will be alkyl group. Clear? In this manner you can write it as, clear, or you can write it as, for example, it will be better if you write it as, for example, it is R and it is H, no matter. Clear? And it is so for example H and it is R. Clear? You can write it as, and so on. Clear? So the wedge, this wedge shows that the hydrogen is toward me and this R is away. Clear? As this structure indicates. Clear? So the hydrogen is away from me and alkyl is toward me. Alkyl is away from me, hydrogen is toward me. Hydrogen is away from me, alkyl is toward me. Alkyl is away from me and hydrogen is toward me. Such type of manner is known as syndiotactic. Tacticity. Clear? Having stereochemistry, having alternate stereochemistry. So again I want to discuss the third type of the tacticity, that is atactic. That is atactic. Here a show no or nor. Clear? No, a means no, absence, a shows absence. So for example, this is a such type of atactic polymer, or such type of polymer which have no tacticity, which have no pattern of tacticity. For example, this is a long chain of what? For example, this is a long chain of polymer, and if the substituent are arranged in such manner, for example, this is R and this is R. Clear? And this is, for example, R and this is H. Clear? This is R, this is an irregular manner. Clear? You can arrange it irregularly. Clear? Or you can write it as, clear? So for example, these are wedges. Clear? These are wedges and these are dash. Clear? So for example, here hydrogen, so and here is alkyl group, so here will be alkyl group, here will be hydrogen, here will be here will be hydrogen, and here will be alkyl group, here will be alkyl group, and here will be hydrogen, here will be hydrogen, and here will be alkyl group, and so on. So this is known as atactic polymer. Clear? So this was the configuration or the classification of polymer on the base of what configuration? Stereochemistry, geometry. Clear? So I hope that you have learned. Clear? So inshallah in the next video we will discuss another classification. So read it, note it, and learn it. So important with respect to all types professional tasks. So okay, if you are feeling that you are learning something from this lecture, then subscribe and also share. Okay.